Bismillah ar-Rahman ar-Rahim. Assalamu alaikum, viewers. How are you? Okay, this session is regarding the solver, and in previous sessions also we went through our experience with the solver and the goal seek. You remember, huh? And the automation, automatically you using the solver and coming up with some random combination of the products like this. And similarly, in the goal seek, we are targeting a certain profit. This is our goal, and while changing the units of the number of units to reach to our desired profit, that is the goal seek. And now we are going to discuss a very important thing, which not only it is for those who are the Excel lovers and they want to improve their knowledge of Excel, uh, but also I'm targeting this to the parents who have children who are focusing to their kids' studies, especially in mathematics, algebra, and numericals and quizzes, etc. So Excel can help you in this, and for to groom your if your parents, your kids, to groom your students. If you're a teacher, you can groom them. You can groom your students using the Excel skills, right? So Excel has come up with the solver and other and the spreadsheet is the built-in feature, which makes you think and design and evaluate the things, right, systematically, and design some solutions, right, using the automation, using the formulas and functions, etc. Right. So one of the function we are at the moment is using that as the solver, and with your understanding of the variable, here we are using the three variable. Like this is a, for example, n, a special n. How I managed to get this n. Just treat it, for example, z. Z. Let's put a z here, and you will see everywhere. You will find this n is turned into z, right? So this is linked, right? And let me undo it. Oh, so it is back to the n, the beautiful n, right? Okay, so this is n2, this is n3, this is n1, right? And even this is integrated. Whatever the solution you get through the solver, these are the green cells. These are going to be used by the solver to arrive to your desired maximization of this equation, algebraic equation. You want to maximize the objective. That, for example, it is P. The P is maximized when you run with a certain combination, right? So you get the result. Right? Okay. For example, uh, your algebraic objective is the 2 times of n1 plus 2 times of n2 minus 1 time of n3, right? And so what would be the maximum, keeping in view these constraints, right? These constraints are not written by us. You can see these are the formulas in it, and they are focusing these things, right? So whatever you do, you just type your values in here, so the equation is appeared here. That's fantastic, isn't it? I mean, so you don't have to worry about the algebraic notation. Excuse me. You have to just use this matrix, change the values, and you will see the algebraic notation will be updated, and the solver is going to be used. It's going to use it as soon as it comes up with some with the result, maximized result. So this result is picked up. It is changed automatically. So what this command is there, it is seen if it is blank, right? If this comes to be the blank, right? So there it is not going to write anything, right? So D10, if it is blank, then nothing is written in here, right? And similarly, uh, as soon as the value is here, so it is going to pick the p value is this, which is the result of all these things, right? The algebraic notion is this, but the Excel, in Excel language, you will write that 2 and 1 is 2 and 1. So this is 5 into 2, 10, right? And so 10 is here, and then 2, and so similarly this, and then minus 1. So that makes 11, right? Okay. So these are the functions you have to use, and then you go to the solver. For example, you put in here the value, for example, say you make it 3. Okay. Okay. So this is 3. So let's use the solver to determine. So our objective remains the D10, D10. That's right. Okay. So, and it is max. Fine. And then the changes will appear here. It will keep changing these values. N1, N2, and N3. So E3 is actually N1, right? E3 is N1, and G3 is N2, and I3 is N3, right? So these variables are set like this, and then you use the constraint. There are two sorts of constraints. Number one is that this notion N1 and 3 and 2, yeah, plus N3 is less than 9, right? It has to be less than 9. This has to be greater than 2. So 14 is, of course, greater than 2. And so whatever it is greater than 5. So it's a minimum restrictions have been applied. And other constraints are like this, that N1 is greater than or equal to 0, right? And that is E3, right? E3, that is N1, yeah, N1 is greater than or equal to 0. And N2, N2 is greater than 0, that is greater than or equal to 1. That makes the same sense, right? So because when you add it, so it will be greater than 0. So 0 is excluded. So anything higher than 0, that is greater than or equal to 1. That's same thing. And I3 is greater than or equal to 1. That's right. So greater than 0 means greater than or equal to 1. Both are the same thing, right? Because solver does not have this option only greater than. It has the when you add a new constraint, right? It does not have anything like greater than only. It has greater than or equal to. So for this, you have to change it from 0 to 1, right? Okay, that's right. So your purpose is to solve. The next thing you do, you make sure that the non-negatives are ticked, and the simplex LP we are going to take. We are going to stick. We are not going to stick to the other thing, the other mode of the solving, and then we will click OK. Right. So it has come up with the solution. Okay. It has come up with the solution. That's 11. Okay. So this is how we use the solver for arithmetic computation, algebraic equation solution. Okay. I hope you liked it. Thank you very much, and see you in our next session. Okay, we will be discussing more application of Excel in the algebra and the numerical, which in the numerical computations and the functions and the scientific use of the Excel. Thank you. Rahim. Assalamu alaikum, viewers. So our today's topic is about the linear equation solution, in which we are going to maximize. We will show you how to use the maximize function. Say for this, we have used an illustration of cake production. So let's maximize our cake production. So just suppose that we have an enterprise in which we produce the cake on daily basis, and so we have the two variables here. The two types of cakes we produce, the Black Forest and chocolate, for example, right? So BF is the variable for the Black Forest, and C is for the chocolate categories, right? And this is the solver is going to use these two inputs, right? How many cakes to be produced to maximize this function? What is the function? The function is that 4.5 pounds of the Black Forest cake and 6 pounds cake for the chocolate cake, right? So these are if both are 1 cake each, in the each category we have 1 cake, then 10.5 pounds production of the cake system, right? 4.5, you take 4.5, you can make this is all done, it is interlinked, right? So these are the two variables, right? You can use a different, for example, variable when you will be trying, for example, you can use let me show you one important thing, that you can use uh, different symbols for the variables, right? This is also very interesting. Let me show you. If you go to the insert, you go to the symbol, you go to the symbols. There are so many symbols in here which you can use for your algebraic expressions which you are using. For example, you want the cake. This is a black for the Black Forest cake. I think let's use any symbol which is, for example, this. Okay, we insert it. Okay, that's right. Okay, so it is inserted. Now we use we remove this after that, just to show you that how it comes. Okay, so these are interview. Even in the result, you will find that Black Forest will be like this. Okay, so how we have done it, you can see that we have used we have linked everything with the cell, and whatever is in here, it is means how whatever that variable is defined in here, these are linked until throughout the model. Okay, so simple as that. There's nothing rocket science in that. So we have the two variables, right? And we have this function, maximize function, and we have to ask the Excel solver add-in that how much production it will be feasible, keeping in consideration of these constraints. So what is the best way to maximize our production, right? And how many cakes of the Black Forest and how many of them, what combination of these two cakes would be suitable in order to maximize this function and taking into the consideration of this that you can have different stuff. So this is a part of the capacity planning, what or your limitations which you have in the production floor, the hours or machine hours which are available, or the manpower, the skill set which you require, and the bomb of the material, whatever. These are the things that you can use these constraints. You can even add further more constraints in it, and then you apply it in these things using the solver, right? So let's start the solver. We go to the data, we go to solver, and here we reset all, and then we set our objective to this p value. Yeah, that is our so our objective is D10, right? To maximize. Can also use the solver for different other things, right? Okay. So for the moment, we are focusing how to maximize our production, right? Okay. So there can be some other thing. For example, if you are using the solver to minimize the waste, to minimize the cost thing, and then you are going to use what's for the moment we are focusing on the maximization. So this is all you need to do is specify what you want to do and maximize. Next is now changing variables are only these two variables are changing. That is the how many that is E3 is the Black Forest and G3 is what it is the chocolate cake. So it will keep on changing until it reaches to the highest value of the P, right? And in this, it is paying attention to the constraints which have been provided. That B and plus C, the Black Forest plus the chocolate, it should be less than or equal to 30, right? And similarly, one Black Forest and plus two means a double of the chocolate. It should be less than 40, for example. And two Black Forest plus four times the chocolate, it is less than 80. Another constraint is that by saying greater than or equal to 0 here, E3. So by saying this, we are telling to the computer that don't go to the minus things. Always attempt all the numbers which are greater than or equal to 0. Don't go to the negative side. Okay. So similarly for the chocolate ones as well. Okay. So all you need to do is select the proper method, the solving method. There are other methods as well. So since it is a simple let's LP method, it is most appropriate. All you need to do is click solve. So it has come up with the solution, and not only here, it has picked up the value in here as well by me. So it's the same formula, right? That maximum value of the P is 150, right? And where Black Forest will be 20 and the chocolate will be 10, right? So this is the beautiful example, the beautiful function of the solver which you can use in your day-to-day activities. The production managers can use it, and you can use it in a number of ways, wherever you want Excel to support you for your efficient decision making. Okay, so this was the example of the solver, and I look forward to your participation in my forthcoming further enhancement and further discussion on these Excel tips which are being prepared for you. For all my audience are not only the managers, sages, my audience are also those parents who want their children to be groomed to apply the Excel expertise in their day-to-day studies, and my also the concepts which I am presenting, they are useful for the teachers as well. They can use Excel to groom up their students, and managers can also use it for all sorts of managers who want their team to be groomed up. to use the automation in their day-to-day departmental activities. Okay, thank you very much.